Hubble is an upgradable space-based telescope orbiting at almost 600 kilometers, placing it well above most of our image-distorting atmosphere. It takes about 97 minutes to complete each orbit. It is designed to take high-resolution images and accurate spectra by concentrating starlight to form sharper images than are possible from the ground, where the atmospheric twinkling of the stars limits the clarity.
To gather as much light as possible from the faint objects it observes, any telescope needs the largest mirror it can get. Despite Hubble's relatively modest mirror diameter of 2.4 meters, it's well able to compete with ground-based telescopes having mirrors that are 10 or 20 times larger in collecting area. Hubble is a large satellite, about 16 meters long, or the size of a small bus. It's also one of the most complicated pieces of technology ever built. It contains over 3,000 sensors that continuously monitor the status of the hardware, so that technicians on the ground can keep an eye on what's happening. Time on Hubble is a precious commodity. Astronomers around the world regularly ask for much more time than is available. Keeping Hubble operating 24/7 is no small task. Not a second must be lost, and all operations, from observing to the so-called housekeeping tasks, such as repositioning the telescope or uploading new observing schedules, are meticulously planned. For astronomers, the most important components of Hubble are its scientific instruments. There are two groups of instruments in Hubble, here and here. The different instruments serve different purposes. Some are for making images. Some are designed to dissect the light from the stars and galaxies by spreading it out to form a rainbow-like spectrum. Hubble's unique vantage point in space makes it capable of observing the infrared and ultraviolet light that is otherwise filtered away by the atmosphere before it can reach telescopes on the ground. These forms of light reveal properties of celestial objects that are otherwise hidden from us. Some instruments, like ACS, the Advanced Camera for Surveys, are better for visible and ultraviolet observations. Some, like NICMOS, the Near-Infrared Camera and Multi-Object Spectrograph, are best for infrared observations.
Different mechanical and electrical components keep Hubble functioning. The power for Hubble comes from solar panels on the side which convert sunlight into electricity. Gyroscopes, star trackers and reaction wheels keep Hubble steady and pointing in the right direction, not too close to the Sun, Moon or Earth, as they would destroy the light-sensitive instruments, and accurately towards the objects being studied for hours or days at a time. Hubble has several communication antennae on its side that are necessary for sending observations and other data down to Earth. Hubble sends its data first to a satellite in the Tracking and Data Relay satellite system, which then downlinks the signal to White Sands, New Mexico. The observations are sent from NASA in the United States to Europe, where they are stored in a huge data archive in Munich. No single nation could undertake such an enormous project. Hubble has been a major collaboration between NASA and ESA, the European Space Agency, from an early stage in its life. Hubble has been of paramount importance to European astronomy. European astronomers regularly win more than 15% of the observing time with Hubble, resulting in several thousand scientific publications over the years. Two groups of European specialists work with Hubble. There are 15 people from ESA currently working at the Space Telescope Science Institute in the USA, and 20 others make up the Space Telescope European Coordinating Facility in Munich, Germany. are no boundaries in space. In this vast universe, our closest relatives are the objects within the solar system. We share the same origin and the same destiny.
Our solar system was formed about 4.5 billion years ago from a huge gas cloud. Ironically, it could have been the deadly force of a thermonuclear blast from an exploding star in the vicinity that triggered our creation.
The devastating force of the blast may have disturbed the precarious equilibrium of the original gas cloud, causing some of the matter to collapse inwards towards the center, creating a new star, our Sun, and a minute percentage of the collapsing matter became the multifaceted assembly of planets that we have around us today. We are, in other words, just the leftovers of our Sun's birth. The planets were born in the rotating disk of dust and gas left behind as our mother's star was formed. The rocky planets formed in the inner solar system, while the enigmatic gas giants were formed farther out. And then, when a fierce wind of smashed atoms began to blow from the Sun, or perhaps from hot nearby stars or a nearby supernova, only sizable planets could maintain their gaseous surroundings, and the last wisps of the tenuous cloud between the planets was whipped away. So in our solar system's zoo of celestial bodies, there are rocky worlds and giant gaseous planets.
Even now, there's no exact estimate of the amount of matter, or even the number of planets that exist in the solar system. Since Pluto's discovery in the 1930s and its satellite Charons in the 1970s, astronomers have been trying to figure out if there's anything else out there beyond the 9th planet. In 2003, Hubble spotted something moving fast enough across the background of faraway stars to be an object within the solar system. Estimates show that it could be about the size of a planet, and it's been named Sedna, after an Inuit goddess. Sedna may be 1,500 kilometers in diameter. That's about 3/4 the size of Pluto, but so far away that it appears just as a small cluster of pixels, even to Hubble. Nevertheless, it's the largest object discovered in the solar system since Pluto.
The Sun is about 15 billion kilometers from Sedna, 100 times further than Earth's distance from the Sun, and barely gives out as much light and heat as the full moon. So Sedna is engulfed in an eternal bleak winter.
Sedna is not the only mysterious object out there. Debris from the formation of the planets is still floating everywhere in the form of asteroids and comets of various shapes and sizes. Sometimes their orbits can lead them on catastrophic courses.
The Hubble Space Telescope witnessed the final journey of the comet Shoemaker-Levy 9. It was torn into numerous pieces by Jupiter's gravitational pull when it passed the massive planet in the summer of 1992. 2 years later, these fragments returned and drove straight into the heart of Jupiter's atmosphere. Hubble followed the comet fragments on their last journey and delivered stunning high-resolution images of the impact scars. Our Earth could easily fit into any of these black bruises.